Welcome to the lesson on 12-volt systems. In this lesson, we will cover several key aspects related to the 12-volt system in vehicles. We will begin by identifying its primary purpose and recognizing its components. We will then explore the unique characteristics and challenges of the 12-volt system specifically in battery electric vehicles. We will delve into the role and functionality of the DC-DC converter in a BEV, which is important for maintaining compatibility between high-voltage components in the 12-volt system. We will also compare and contrast 12-volt systems in internal combustion engine vehicles and BEVs, highlighting differences in power sources and system complexity. Further on, we will analyze the challenges faced by 12-volt systems, including voltage stability and battery degradation, while understanding the maintenance requirements and life cycle of a 12-volt battery. Lastly, we will explore advancements in low-voltage technology and their impact on automotive electrical systems, considering innovations aimed at improving efficiency and performance. In the early 20th century, automotive electrical systems were relatively basic, utilizing 6-volt systems. This was sufficient due to the limited electrical demands of vehicles at that time. However, as automobiles evolved and became more sophisticated, there was an increase in consumer demand for additional electrical features. These advancements necessitated the development of systems with greater capacity, leading to the transition from the traditional 6-volt systems to systems capable of supporting the increasingly complex and power-intensive requirements of modern vehicles. The transition to 12-volt systems in the 1950s marked a significant evolution in automotive technology. This change was widely adopted during the period, primarily because it allowed for the use of smaller, lighter wires, significantly reducing the weight and cost of wiring harnesses in vehicles. The benefits of this increased voltage were substantial, notably improving the overall performance of electrical components. It led to brighter headlights and more reliable engines starting, particularly in cold weather, enhancing the efficiency and reliability of automobiles during that era. The electrical system of a vehicle is vital, not only for starting the engine, but also for powering a range of electrical accessories and ancillary components that enhance both the functionality and comfort of the vehicle. These include headlights, ensuring visibility during nighttime or adverse weather conditions, interior lighting that provide visibility and ambiance within the vehicle, radio and infotainment systems that offer entertainment and information to passengers, windshield wipers that are essential for maintaining visibility during rain or snow, and the starter motor, a critical component for igniting the engine's combustion process. Each of these components plays an important role in the modern driving experience, making the electrical system a fundamental aspect of vehicle design and operation. Now let us examine the various parts of a 12-volt system in conventional vehicles. They are the ignition switch, power module, connection to coil, external voltage regulator, starter relay, dashboard indicator light, starter motor, ground, alternator, drive belt, and the 12-volt battery. The ignition switch is a key-operated electrical switch that controls power distribution to various components of the vehicle's electrical system, including the starter, ignition coil, and accessories. The power module regulates and distributes electrical power within the vehicle's electrical system, ensuring consistent voltage levels to components such as light, sensors, and electronic control units. The connection to coil delivers electrical power from the ignition switch to the ignition coil, which transforms low-voltage current from the battery into high-voltage pulses to ignite the fuel-air mixture in the engine cylinders. The external voltage regulator regulates the charging voltage produced by the alternator, ensuring that the battery receives the correct charging voltage to maintain its charge without overcharging. The starter relay is an electrical switch that controls the flow of electrical current to the starter motor. When activated, it allows high current from the battery to flow to the starter motor, enabling engine cranking. The dashboard indicator light illuminates to provide visual feedback to the driver, indicating various conditions such as low battery voltage, charging system malfunction, or engine-related issues. The starter motor is an electric motor that rotates the engine's crankshaft to initiate the engine's combustion process. It receives electrical power from the battery and is activated by the ignition switch. The ground connection provides a return path for electrical current to flow back to the battery. It ensures proper electrical circuit completion and prevents electrical issues such as voltage drops or shorts. The alternator is responsible for generating electrical power while the engine is running. It converts mechanical energy from the engine into electrical energy to recharge the battery and power the vehicle's electrical systems. The drive belt connects the alternator to the engine's crankshaft, transmitting mechanical power from the engine to drive the alternator and other accessories such as the water pump and air conditioning compressor. And finally, the battery, also known as the 12-volt battery or auxiliary battery, stores electrical energy in chemical form and provides power to start the engine and supply electrical power to various components when the vehicle's engine is not running. Do battery electric vehicles also have a 12-volt system? Yes, they do. BEVs are equipped with a high-voltage battery pack, primarily designed for propulsion, providing the electric power needed for driving the vehicle. Alongside the high-voltage system, BEVs continue to feature a 12-volt electrical system that remains an essential component of the vehicle's overall functionality. A critical element of this 12-volt system in BEVs is the DC-DC converter, which plays a vital role in stepping down the high-voltage electricity generated by the main battery pack to a stable and usable 12 volts. Importantly, the 12-volt system operates independently of the state of charge, or the operation of the high-voltage battery pack used for propulsion. This ensures safe and reliable functioning of accessories, irrespective of the vehicle's driving conditions or charging status. Let us take a closer look at the DC-DC converter. The DC-DC converter is an electronic device that converts high-voltage DC power from the vehicle's high-voltage battery pack to the lower-voltage DC power required for the vehicle's auxiliary systems and to charge the 12-volt battery. It steps down the high voltage to the 12 or 48 volts typically used by the vehicle's auxiliary electronics such as lighting, audio system, air conditioning system. The device ensures the vehicle's 12-volt battery is kept charged. DC-DC converter is essential for the operation of the BEV when the main battery pack is not engaged, like during low power conditions or when the vehicle is turned off but still requires power for certain functions. This technology is beneficial in lowering production complexity and maintaining costs within limits by enabling compatibility with standard 12-volt vehicle accessories. The DC-DC converter is a critical component for the functionality and safety of electric vehicles, ensuring that all low-voltage systems have a stable and reliable power supply. Presented here is a comparison of 12-volt systems in regular internal combustion or engine or conventional vehicles and battery electric vehicles. The 12-volt system in vehicles primarily powers accessories such as lights, radio, infotainment systems, and various sensors. It is also used for starting the internal combustion engine. In BEVs, the 12-volt system still powers accessories, but it also plays a role in managing the vehicle's low-voltage functions and auxiliary systems. The 12-volt battery in conventional vehicles is continuously charged by the alternator, which is driven by the engine, whereas the 12-volt system in BEVs is charged from the high-voltage battery pack. The energy efficiency of 12-volt systems in conventional vehicles is lower compared to battery electric vehicles due to the energy losses incurred during the conversion of mechanical energy into electrical energy. In contrast, the DC-DC conversion process in BEVs is more efficient, resulting in fewer losses. The 12-volt system in BEVs demands less maintenance than that of conventional vehicles, primarily because BEVs have fewer moving parts. We will now shift focus to some of the challenges of the 12-volt system and their mitigation strategies. Like conventional vehicles, maintaining the charge of the 12-volt battery in a battery electric vehicle is critical since it powers essential vehicle systems. Allowing the 12-volt battery to remain in a discharged state for an extended period can lead to irreversible damage, reducing its lifespan and necessitating premature replacement. Some of the strategies to mitigate this challenge are discussed here. Battery electric vehicles utilize a DC-DC converter to maintain the 12-volt battery charge. This converter steps down the high voltage from the main battery pack to the lower voltage needed for the 12-volt battery, ensuring it stays charged while the vehicle is operational. Systems such as regenerative braking capture energy normally lost during braking and feed it back into the 12-volt battery, contributing to its charge maintenance. This is especially effective in urban driving scenarios where braking is frequent. The vehicle's battery management system, abbreviated as BMS, continuously monitors the state of charge of the 12-volt battery. It ensures optimal performance and alerts the driver in case of low battery levels, helping to prevent breakdowns and maintain battery health. Another major challenge is the power management, especially during maintenance or failure scenarios of the high-voltage battery. BEVs rely on high-voltage batteries for propulsion and numerous functions. Most BEV systems, including power steering and brake controls, rely on the high-voltage battery. Maintenance or failure of this battery can lead to system shutdowns and safety risks. Redundancy and backup power systems are essential to address the challenges of maintaining critical safety functions during a 12-volt system failure. One key strategy is to incorporate power storage devices like capacitors for vital components such as the anti-lock braking system and electronic stability control. These capacitors act as a temporary power reserve, ensuring that if the primary 12-volt system experiences a sudden loss of power, the capacitors can provide enough energy to keep the critical safety features operational for a brief period. This backup power allows the driver to safely maneuver the vehicle and come to a controlled stop, mitigating the risks associated with a complete loss of power to these systems on a busy highway. Let us now look at the maintenance requirements for a 12-volt battery. Regular maintenance is required to keep the 12-volt battery working optimally and extend its lifespan as long as possible. To keep the battery in good condition, it is important to check the battery terminals regularly, ensuring they are clean and tightly connected. Additionally, inspect the battery posts for any signs of corrosion, as this can impede the flow of electricity and lead to reduced performance. It is also recommended to test the battery's charge on a monthly basis using a voltmeter or a battery tester. If the battery's charge falls below the manufacturer's recommended level, recharge it promptly to prevent damage. It is essential to avoid completely discharging the battery, as this can cause permanent damage and significantly reduce its capacity. By following these maintenance practices, vehicle owners can maximize the reliability and longevity of their 12-volt battery, minimizing the risk of unexpected failures and ensuring a smooth operation of the vehicle's electrical systems. We will now discuss the life cycle of a 12-volt battery. The average lifespan of a 12-volt battery is 3 to 5 years. There are several factors that impact lifespan. Extreme temperatures, both hot and cold, cause faster deterioration of the battery. Vehicles in very cold or very warm climates tend to have shorter battery lifespans. Making many short trips that don't allow the battery to fully charge is another factor that affects lifespan. Operating a high number of electrical accessories would shorten the battery life. Deep discharges below 50% capacity could degrade the battery quicker over time. Keeping discharges shallow extends life. The more times the battery is deeply discharged, the shorter the life. Avoiding complete discharges extends life. The end-of-life symptoms such as dimming headlights and erratic behavior from electronic accessories are signs that the battery may need to be replaced. When a 12-volt battery's capacity drops to 50 or 60% of its original capacity, it is time to consider replacing it to ensure optimal performance and reliability of the vehicle's electrical systems. It is important to replace the battery with one that matches the original equipment manufacturer's specifications, including the correct size, amperes, and reserve capacity. This ensures compatibility with the vehicle's electrical system and helps maintain the desired performance levels. Once the old battery is replaced, it is essential to properly recycle it to prevent environmental harm. Lead-acid batteries contain toxic materials that can pose significant risks to the environment and human health if not disposed of correctly. Many auto parts stores and battery retailers offer battery recycling services, ensuring that the old battery is safely processed and its materials are recycled for future use. Let us shift gears to the advancements in low-voltage technology in automobiles. The current standard in both internal combustion engine and battery electric vehicle platforms is the use of 12-volt systems, which perform the duties of powering essential functions within vehicles. However, the industry is witnessing a significant shift towards 48-volt systems, a change primarily driven by the increasing demand for advanced vehicle features such as advanced driver assistance systems and active chassis systems. The transition to higher voltage systems offers notable benefits, including the ability to deliver more power with reduced current. This leads to the development of systems that are not only lighter but also more efficient. As vehicles continue to evolve by integrating an increasing number of electric features and hybrid technologies, it is anticipated that 48-volt auxiliary systems will emerge as the new norm, marking a pivotal advancement in low-voltage technology. The benefits of higher voltage are substantial, primarily due to the ability to deliver more power with less current. This results in lighter and more efficient systems overall. Looking ahead, the future trend indicates a move towards 48-volt auxiliary systems as the new standard in vehicle design. With the increasing integration of electric features and hybrid technologies in vehicles, the higher voltage offered by 48-volt systems is positioned to meet the evolving demands for improved performance and efficiency in automotive applications. Let us now summarize what we have learned in this lesson. The 12-volt system has been a fundamental component of automotive electrical systems since the 1950s, when it replaced the 6-volt system to meet the growing electrical demands of vehicles. In conventional vehicles with internal combustion engines, the 12-volt system powers essential functions such as lighting, ignition, and various accessories, with the battery being charged by the alternator. In battery electric vehicles, the 12-volt system operates independently of the high-voltage battery pack, using a DC-DC converter to step down the voltage and power the auxiliary systems. Regular maintenance is important for optimizing the performance and lifespan of 12-volt batteries, which typically last between 3 and 5 years. As the automotive industry evolves, there is a trend towards adopting 48-volt systems to accommodate advanced features and improve overall vehicle efficiency. Thank you.